Guys, welcome back. Here we are. We're going to talk about simple and compound interest. This is section 8.1.4. We've talked about step functions, so now we're moving into interest here. So we model the step functions of simple and compound interest with a continuous function. An investment can earn simple interest, in which case the amount of money in the bank account grows linearly, meaning that you get a fixed amount on the principal, which is the initial investment, and they just add the interest only to the initial investment. That's actually a pretty uncommon way of calculating interest, but it is the first way that we learn, and kind of goes back to middle school. So if we look at an example here, a 3% annual simple interest on an initial investment of $2,500 would grow in a sequence with a common difference of $75. In other words, we would start by finding 3% of 2,500, which is $75, and then we would just add $75 during each time period, whatever that time period may be. So each step grows by $75, so on and so forth. Now, the much more common way of calculating interest is what's called compounding interest, and that's what makes interest so powerful, actually, is because we go from a type of growth that is linear growth to exponential growth that is going to grow much faster than the linear growth, especially as time goes on. So there's a lot of power in compounded interest for you, the investor, or for the bank if they're loaning you money in compounded interest, which is also typical. So if a bank compounds interest, the amount of money in the account grows exponentially. For example, 3% annual interest compounded annually, compounded annually would have a multiplier of 1.03. That's because we say 1 plus the 3%. So that's the 1 plus 0.03 equals 1.03 right here. And the equation would look like this. T of n equals 2,500 times 1.03 to the n. And in this case, our n would be years. So at the end of each year, they would give you 3%. You don't get any interest during the year, so that is compounded only once at the end of the year. Another way of compounding interest would be to compound it more often. So in the next scenario, the bank compounds monthly, meaning that at the end of each month, they're going to give you part of your annual percentage rate. So what they're going to do is they're going to take the 3% annual interest and divide it by 12 so that you get 0.25% per month. And that ends up actually working out better for you. Even though maybe you're thinking, what's the difference? They divided it by 12. And then they compounded it 12 times. Because you're earning interest on the amount that you make each month, it ends up being a lot more beneficial, or at least slightly more beneficial. So in this case, if we look at the number of months by plugging them into this equation, we'll notice that after 12 months under the original problem, which would be 1 year, we had 2575. Now we have 2576, and this difference is going to grow with time. So by the third year, where we had 2731, now we have 2735, and after 10 years, there's a difference of $15 or so. Okay? So in general, the amount in an account earning compound interest is equal to this equation. T of n equals A times 1 plus R over P raised to the n, where A is your initial amount, R is the interest rate, R stands for rate, that'll be as a decimal percent, P is the number of times the interest is compounded in a year, and n is the total number of periods that the money is invested. So in this example, in the compounded monthly example above, A, our initial value was 2,500. The interest rate was 3%, which we're going to put in as 0.03. P was 12 because we were compounding it every month throughout the year, so that's 12 times in a year. So we take that 3% and we divide it by 12. That's going to give us the interest rate for each month. And then we raise it to the total number of months that we're actually investing in. So this would be 3 years or 36 months. And then if we wanted to figure out what the total value was after 36 months, we plug in 36 right here, and we end up with this value, 27, 35, and 13 cents, which is what we had up here. All right, so guys, here's your homework problems. Terry has options for investing $1,000. Evaluate each of the options below to determine how much they have in their account after 12 years. Option 1, we're doing a 6% simple interest, meaning it's not compounded. They just get the 6% on the original investment each year. Option 2, they have a 6% annual interest that's compounded annually, so at the end of each year it's compounded. Number 3, 6% annual interest compounded monthly, so at the end of each month it's compounded. And then question 4, what do you think would happen if we compounded the interest daily or even hourly? And we'll talk about that in class, guys. All right.